data catalog is a dead story. There are two things where we tell ourselves a lot of lies. Your data is structured, but your decisions are unstructured. My lake house is like 10 petabytes. It's not a feather in the cap. Don't think of it as a badge of honor. There'll be probably a doctor who'll be like writing 5,000 prescriptions a day looking at these AI outputs. I see compliance and security as accelerators. Everybody talks about prompt engineering. People talk about context engineering, but what nobody is talking about is
Hello, everyone, and thank you for listening. This is your host, Saket Saurabh, with another episode of Data Innovators and Builders. Today, I'm speaking with Mahesh Mishra, Vice President of AI Products at Cloudera. Mahesh, thanks for chatting with me today.
thank you for having me.
Mahesh, tell us a little bit about your journey in data so far.
I have been here in this data and analytics space, including AI, for last 20 years. Primarily, first half of my career, if you look at, I have been an engineer. I'm doing hands-on coding. I joined AWS long time ago in 2011, spent close to 15 years there. Half of my stint there was primarily building data products, and then the second half of it is kind of building the some of those foundational building blocks for customers so that customers can host their data platforms. One of my, I hold three patents in the area. One is for distributed data warehouse management. The other one is to provision data services at scale. The third one is dynamic hierarchy in cataloging. So pretty much very, very deep into, how you do compute management in cataloging. And recently I joined Cloudera close to 3-4 months ago as a VP of AI products. I lead the Cloudera AI product portfolio here. Many of these are, how customers use data to build, train AI models, host, inference endpoints on Cloudera platform, and agentic platform to kind of, build agents that can interact their data with their tools and to start working autonomously. That's who I am.
Yep, great, awesome background. And as we were talking earlier, data and AI are like closely related, close cousins, as we are saying. And your work has spanned in both the areas, especially around when it comes to AI, and you're seeing it from the world of enterprises, right? Like,
Mhm.
what kind of use cases are you seeing starting to hold root in enterprise use deployments?
I think at this point, most of the use cases are focused around kind of engineering the stack itself. For example, many customers build data kind of text to SQL kind of use cases where they can ask plain English business question, and agents can autonomously go kind of look at the data dictionary, figure out which columns may be potentially relevant, and then generate some query that can answer the question. That's a very common use case. Many customers who are little advanced. They kind of do data engineering, where they give a use case, or a data pipeline requirement, for that matter, in plain English, and the system looks at the infrastructure, what is the underlying engine, and then probably if the Spark code is needed, generates the Spark code. If there is some additional, SQL or DBT code that needs to be generated, DB is data builder tool, DBT code that needs to be generated, generates that. Those who are really in production, there are very less number of customers who are really in production. They are actually focusing on low stake tasks, the mundane tasks, generally the data engineers or the operations teams try to do. For example, going through the log when a job fails and figuring out what happened, and then fixing it automatically. For example, many times if you're a data engineer, worked in the data platform for a long time, what you would see is people don't communicate well within the enterprise, and somewhere some data type changed, and that causes a cascading failure everywhere. And those kind of trivial changes, but that needs people to pay attention. Those kind of trivial mundane task is automated by AI. So these are common use cases that I see. There are customers who are thinking about putting some of the high stake decision making as part of agentic flows, but I haven't seen a lot of customers who are actually very successful in that, given given the space is evolving and there is a lot of risk and regulatory requirement involved with those high stake decision making. Make sense?
Yeah, yeah, makes sense. And from a business side, we have seen like customer support has been one area where a lot of companies have built solutions or shown success. And I'm seeing more and more kind of tools around go to market that are being becoming agentic, right? Of course, not to
Absolutely,
mention on
yeah.
the vibe coding side, right? So um, the business impact is definitely also starting to show, right?
I see. Yeah, yeah, that's true. This customer care use case or customer support use case is something that's quite frequent. I come across that. There are very interesting use cases in the law enforcement space also people are thinking about. So uh, for example, if you look at law enforcement uh, officers, what they essentially do, half of that work is basically paperwork, right? So some incident happened, they have to now fill up the paperwork. Even though you have called 911 and given all the information there, they still do that paperwork. So many companies are thinking about how they can reduce that burden from the law enforcement officer. This is an interesting area as well.
Oh yeah, and that reminds me of similar use cases I'm seeing in the healthcare world, where doctors have exactly the same thing going on, right? So definitely a lot of process efficiency and automation of work flows going on there. One thing that you mentioned that is very interesting is that you of course hold a patent in the catalog space, right? You said multi-level catalogs, and we were talking a little bit about knowledge engineering, and I think we touched on some of these topics here. So tell us a little bit about, what is knowledge engineering and how is that playing a role in better AI outcomes?
I think knowledge engineering becomes very relevant in the conjunction of data and AI space, where you are using AI to do a lot of data processing or using AI to use data to kind of make some critical actions or decisions in your enterprise. And everybody talks about prompt engineering as a layer of instructions to the LLM to do certain tasks. People talk about context engineering, where you provide more information about the problem you are solving, so that agent has an informed decision to make. But what nobody is talking about is knowledge engineering, and the way to describe knowledge engineering and context engineering in comparison is context engineering is point in time. Someone wrote in the prompt or someone gave a tool where and tells the system to read the context from this system, and that's a point in time view of the world. And that view may change, but it has a source of truth system, and then it extracts from there. But when it comes to knowledge engineering, think about it as a human baby, and when that human baby grows, it learns from its own experiences. It does some task, it makes mistakes, then someone tells him, hey, no, that's not the right thing to do. Then he course corrects and then evolves, right? Knowledge engineering is exactly that, bringing that experience meaning learning through experience layer to the LLMs. So it has three components. One is knowledge acquisition. There should be strong mechanism to go and gather knowledge from the places where it is documented or stored. I call them. It's a word which is there since like last 30 years, but given the technology was naive then, not a lot of understanding into graph type databases, that didn't kick off. But now is the time that we should think about it, because we have LLMs who can understand structured unstructured data together. So these knowledge scouts can go to the knowledge sources and gather knowledge. For example, generally there is a disconnect in your data platform world, that where the decisions are being made, they are made in either Slack messages when people are talking with each other, some meeting room with a bunch of people sitting there, or maybe in a Zoom kind of call, right? And once those decisions are done, either they go get land in some Jira ticket or somewhere in the GitHub code, or things like stays in the Slack threads. So think about it. Your data is structured, but your decisions are unstructured. You need to combine them together to build this knowledge base. That is your true context layer, because it captures not just what the data means, it also tells what is the reasoning behind why certain decisions have been made. Why? and when and who made that decision, a ton of other associated metadata with it. This is your knowledge scout and actual knowledge repository. Then you need to train your agents to make calls. That's where the blog post, if you have read, there are two concepts that I am a strong proponent of. There is decision flow language and decision tracing language. A decision flow language tells the LLM what to do, what are those alternate criteria to evaluate certain things, and when do you say something is passed versus when do you pass it to a human to correct, right? And then tracing is basically after the fact, when you need to do the postmortem, you need to understand what was the reasoning behind certain decisions. Tracing is basically a language where you store all the traces that generated by a LLM call. I think all these, your knowledge base, which is self curating, and your DFL and DTL layer, the decision flow language layer and DTL layer, needs to be fed together to say, here are the decisions, high stake decisions that we made, and here are the decisions where human were involved. Here is the correction made. Going forward, this is the new decision flow that we need to follow. I think that flywheel has to move to be able to build a strong knowledge engineering platform where it is not only gathering the knowledge and storing it as a point in time information, it is also, making decision flows, learning from its own mistakes, and then having a self-aware kind of layer that is evolving its decision making capability. That kind of makes sense.
Yeah, yeah, I think that totally makes sense, and especially kind of goes into the fact that if we want to bring AI into certain workflows and operational aspects, of how a team works, how a function works, then you do need that sort of traces of decisions and how those decisions were made. And then one of the things I've been thinking about in this whole thing is that there are certain decisions which are kind of could be high impact but low stakes, in the sense that low risk decisions versus their high risk, high impact decisions, that they're ones that you can start to automate because there's enough context around that, there's enough knowledge around it, there are enough decision traces. And then there are ones that are still going to be, like human driven, where a lot of judgment is involved.
There is this example. Say you are doing you are a bank and you are doing some underwriting, right? Underwriting is not a black and white decision ever. You have to look at a bunch of metrics like, what is your asset to liability ratio, what is your income to debt ratio, then how many times you have made payment defaults, and those, a ton of data around your profile itself. But it's never a black and white decision when you approve a loan. It's sometimes like, okay, you had a default payment 6 years ago, that's not as relevant today, right? Generally, if a LLM is making that decision, every time it sees someone is a defaulter, it will say, no, I am not going to approve it, I'm going to involve a human. But if the human looks at the data and says, okay, this was 6 years ago, but the last 5 years or 3 years, it is like the person is doing consistent payments, the debt to income ratio looks good, I should approve it. 3 times the person does it, LLM, it should be fed back to the LLM, and LLM should autonomously make that decision going forward. I think these are something that I say that knowledge ware will be super handy when you have data driven workflow. You have context, which is point in time information, plus that context gets evolved with these decision flows and traces.
Yeah, or at least even if it has to come to a human review, all that information is laid out in front of the person to say,
Very
well,
clearly. Yep.
this is the thing, here's why it should be a yes, or here are some factors why it should be a no. And, that just simplifies the function. I would say even reduces sometimes the variability around that, which may be hard to explain otherwise. So, um, a quick question here. When you talk about the decision flow language, decision trace language, and the knowledge engineering layer, are there tools for that today? Do you see that being solved, or is it a collection of, maybe disparate capabilities kind of getting there?
There are no such tools today. Everything is embedded within a prompt. The decision flow is embedded within a prompt, and decision traces are sometimes open telemetry, but not the real traces are being stored there, to be honest. So the blog post that I wrote, it is basically calling the developer community and think through this problem and come up with an open standard for both decision flow as well as decision traces. It doesn't have to be a new prompt language. It has to be a language where a LLM can automatically define a flow, and once that flow is being executed, everything is traced, and then they fed back into the context layer to make it more mature. I think that is kind of the proposal where I am writing something as a project. myself, I'll open source that and see how people are going to use it and give me feedback there. It's very early stage, so I don't want to say that it'll solve world hunger, but it'll start from a baseline is what I'm trying to say.
Yeah, I think that's a very relevant set of information if you are able to capture this over time. And then, depending on what operation you're doing or depending on what question you're asking, the AI model is able to retrieve the right set of pieces of information from that, right? And you're right that a lot of the decision tracing is in Slack, is it in call recordings, and now all of those data sources are available to be ingested, to be processed. Um, do you think it also then becomes a bit of a context management problem because you can very quickly fill a lot of noise with this as well, right? I mean, the amount of data being generated in Slack and calls and documents is also huge, right?
Yeah, it'll be. I mean, we. I know that this will be a lot of noise, and there is always a human intelligence relationship that decides what is really a knowledge noise versus what is a fact. For agentic workflows, we need to find out some of those mechanisms where it can filter out noise from the actual fact. I do not know what is the solution, but welcome. Ideas are welcome in this space.
Yeah. And you talked about the human learning process where we learn and then we get reinforcement and we also forget things, right? And but then at the right time, we also remember the right pieces of information. And maybe there's a mechanism or a parallel to that where it can have a huge, I mean, I can imagine this being, you know, easily like a terabyte, petabyte scale data eventually over time as you capture that to be able to then pick the right pieces out of that. But fascinating. Yeah.
Yeah, these are some of the areas where we need to start thinking.
Mhm.
Um, because slowly we'll move from these low stake decision making into high stake decision making using AI, and that's when a auditor comes in and say, okay, show me all the, how did you decide this person is approved for a loan? If you don't have the traces, you are like, you don't know. You cannot just say that the computer approved it. I don't know.
Yeah. 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 Um, Earlier on in the conversation, you also mentioned like different stages of adoption of AI in execution at different companies, right? And tell me a little bit, like, because this is a big question for people between going from prototypes to production level use cases. Is where are people missing the point? What are the big gaps? Um, and if it's the knowledge layer a part of it as well. Yeah.
Yeah, I think we talked enough about the knowledge layer, and we
Yeah. Yeah. Yeah.
probably at this point, all the audience would be aware of what it means and how to think about it. There are two things where we um we tell ourselves a lot of lies. For example, every time there is a change after a model, right? After a point, you don't want a model which is more intelligent. And models are not the most difficult part in your AI journey. Um, at least in this cloud, uh, with cloud platforms out there, every intelligent model is just an API call away. So overthinking about models is one of the things which is the reason why people don't move from prototypes to production. The second one is when you do a demo, um, all your assumptions are right there, right? So all your assumptions are true, and then you are doing a demo. Production is an entirely different ballgame, where you have messy data, you have lack of context, you have columns named in a certain way, but you know that that column is deprecated, so LLM, it can always hallucinate. There are access control policies, governance that you need to adhere to, and then you need to be, what is slowness versus what is the fast output of a query. The the LLM cannot decide whether it is acceptable performance or not. You need to be able to have all the challenges sorted out before you go to production. What generally people do today is they do a prototype, they like it, and then they're within that cycle of improving that demo or the prototype, never thinking about how can I take it to production, because production is entirely different ballgame. Third is platforms are not necessarily ready for read write workloads. The data platform itself are not ready for agentic read write workloads. And the reason why I'm saying it, Lakehouse is great, where you have a decoupled storage, you have a catalog which stores the table definitions, you have decoupled engines which query the data. But the challenge there is when human operates against it, human makes some decision, human have accountability, and when they are given the responsibility, they also are accountable. When a machine is offloaded the same task, you need slightly different primitives, where you need to have branching kind of GitHub like primitive, where you create a branch on the data, where you make your commits, the machine makes the commits, and then there should be a second set of agents who should read the committed data set and stamp them that this is accurate. After that, the merge needs to happen. All these primitives are there in bits and pieces in Iceberg world, but nobody is thinking about these new primitives are needed because more and more agents are going to work on this data going forward, right? So that's an area that there is a ton of investment needed. Then I said, like, we talked about knowledge engineering. The key problem there is your decision happens elsewhere, your data catalog is elsewhere. Data catalog is a dead story. Let's I mean, this is probably a very big statement that I'm making, but the truth is you need an army of people to maintain a data catalog. You cannot sustain if your agents are actually making decisions, agents are working with the data, your catalog or whatever that layer is needs to evolve at that pace. For that reason, you need to have this layer which constantly maintaining that metadata layer with right accurate information. Otherwise, your entire enterprise is getting wrong results. So that's an area where people are struggling. So they're really, the platform is not ready, and we are into this LLM discovery churn, that we are not thinking about all this boring work that needs to be done to be able to get to production.
Yeah, yeah. No, I think that's very fair that there's a lot of groundwork to be done. And when we talk about agents using data versus a human does come with a lot of context, business know-how, domain knowledge, right? And agents don't have that. Very interesting observation you made about catalog. And I'm very curious, like, do you see catalog as a space just becoming automated where just LLMs are updating that information? Or does it not need to exist at all? Or is it a different form or shape?
I think about a knowledge layer where the dots are connected. Catalog is a place where it enriches. Everybody talks about knowledge graph. If you look at the catalog space, if you go to Quilibra's website or Atlan's website, what you're going to see, I'm not saying these are bad products. These are really good products. They're solving real good problem so far. But if you see, everybody is calling it a knowledge layer without understanding what actually is needed for AI agents. A knowledge layer that needs an army of people to maintain it is not a knowledge layer, because it is going to stale very quickly, and and your agents are looking at really wrong knowledge to make decisions. So the catalog as a layer needs to rediscover itself. It has to become a semantic knowledge graph with which is all we need is a physical metadata store and semantic knowledge graph that connects the dot between how the tables are joined, what each column means, what formula needs to be applied to kind of generate this metric, which one is a dimension, which one is a fact. Then a bunch of decision making flows that has happened on top of this data. When a marketing user asks what is my churn rate, I use this flow. This has to be documented in the catalog itself, that so that next time a marketing user is asking the same question, probably same flow can be used, or an enhanced version of the same flow can be used. So the catalog just being a metadata repository is going to die. It needs to evolve into something like a knowledge graph, with all the knowledge engineering practice that we talked about, storing the decision flows, storing the decision traces and summaries, then having knowledge scouts who can scout into different knowledge sources and bring knowledge together and then enrich that knowledge graph. Without all these three core integration layer, catalog as a product will slowly become obsolete. I'm not saying the technical data catalog like Iceberg REST catalog that will always be there because engines depend on them. I'm talking about this, business data catalog layer, which actually call themselves as knowledge layers today.
Yeah, yeah, that's a fair point. Do you feel like the different components of data management, whether it's integrating pipelining data, having the catalog or observing the data, all of those pieces probably converge in to a single system that can just feed the whole cycle continuously. You're integrating, you're moving, you're updating, you're observing all that stuff. And the reason I'm asking is, you mentioned DBT earlier, and 510 DBT merger just closed, right? So just curious what your sort of perspective is and how that space evolves.
Again, this is my strong opinion. I may be totally wrong here. Um, so my thinking has been every vendor out there in the market is looking at the world in a very narrow view. For example, DBT is looking at from the point of view metric generation and transformation of data, and that's the world they are confining themselves. And that's the assumption layer that is baked around all the things that DBT is going to do. Similarly, if you are going to look at Databricks assumptions are, hey, all the data needs to be there in Databricks platform with Unity catalog on top of it, and then they build everything around it, which works only if the enterprise uses Databricks as the platform. So so the problem that I'm seeing is none of the enterprises are so clean today. If you go to any enterprise, they have some on-prem, there's something on the cloud, something on Databricks, something in Snowflake, something in Cloudera. So the data platform itself is so messy that having this myopic view of the world or myopic assumption while building these primitives is not going to work in the long term. We need to think about a layer which is open standard, which sits on top of all these data services. Maybe it is Unity Catalog, Atlan, Colibra, Cloudera, or whatever it is, right? There has to be a one horizontal layer which is open source driven with open interfaces for the AI agents to interact with it, and then integration with all these platforms from which it can extract information and store it. I think this is one single layer which is missing today. That can be just the interface for your entire enterprise's institutional memory that the agents can access. Yeah, so all these primitives have been built, um, where you have branching, tagging in the Iceberg data, and that way you are ready for the agents. Where people generally go wrong is they think that the lakehouse layer itself is a product. It's actually not a product. It's a conscious architectural choice for people to make. It is more complex than a simple data warehouse. We just discussed that, where data warehouse abstracts out all the complexity of a table, whereas you now have to manage a lot of things. And then when you go into agentic world, you also need policies, governance, stressing, all these additional work that needs to be done. So your simple warehouse in this modern world needs to be thought through slightly differently. You need three core layers for sure: a storage, a technical catalog to store your table definitions and everything, and then your decoupled engine. On top of that, you need to be able to have a policy and governance layer which doesn't have a real open source specification as of today. So someone has to build that, right? There is no notion of single identity across the board. Go to any catalog, unless it is a managed one by some vendor, you wouldn't get an open source specification about what is an identity, what is a policy definition, what is the policy grammar, how to write fine grained access control. So these are some of the things people don't think upfront and get into this world of modern lakehouse architecture, and then eventually realize that it's a lot of thing to manage, and they try to retrofit everything and to their this new world with to their old world going forward. I think those are the things that people make mistake. Then there is operational challenges in the old world. In the data warehouse world, data was stored, it was automatically optimized because there was a tightly coupled engine sitting and it had compute power to do automatic storage optimization. In the world of lakehouse, storage is separate, so you need additional maintenance work to be done, like compaction, reordering, sorting, to keep your storage layer really efficient. And these are some additional considerations people do not think upfront, and they will realize that they are caught by surprise when either their query runs slow, or or their policy gets violated.
Yeah. So a lot of thoughtful decision making has to go into this whole process, right? But the one
Yep.
advantage, of course, with Iceberg is that multiple engines are supporting Iceberg at the storage level, right? Um, as we go into the world of more AI applications and stuff, and we said like the foundations have to be in a good place. Uh, do you see Iceberg sort of serving that need in a way that maybe the world of data lakes and lake houses and databases sort of converge together um into one in a way? You're storing on Iceberg using different engines.
Iceberg is definitely useful and important for structured data analysis. But until today, um, in this agentic world, what is unstructured data is equally important as structured data. So, the way I look at the world is there needs to be open format like LansDB, right? Which has vectorization in the object store. They store the vectors in the object store and provide kind of a table-like primitive. That is for unstructured data, and Iceberg as structured data, and both Lance and Iceberg together complete the whole story for the AI adoption.
That's a great point. And what's your take on? I mean, we've seen a very rapid adoption of tools like Superbase, for example, running on Postgres, right? Um, eh, and they also are, of course, dealing with both structured data and embeddings all at the same time. Like, do you see some of these databases like resurging and um, sitting side by side with Iceberg, or how do you see that?
We have gone through this cycle multiple times in last 30 years, that we know at this point that no single database can solve all the use cases. Your online use cases sorted by databases, your offline use cases object store, probably there is a hit on the performance, but we are that's why we are calling it offline data store, right? So I'm pretty sure Superbase will come along. It'll have a super critical role to play in this space, but you would definitely need three types of two types of storage. One is object store for your offline data, because as agents will make these decisions, you think how much of ancillary data, the traces and additional data that needs to be created. If you are storing in something like Superbase, it's going to become super expensive, right? So there is Superbase kind of, Postgres also has now a vector extension, PG vector, and also there is a graph extension in the Apache community for Postgres. So all these things definitely make sense for online workload where your workload is actually needing low latency, high concurrency, that kind of workload. But you are working against a limited set of data sets, probably a few terabytes at a max. But when you are doing like historical analysis, decision traces for last 5 years, if I have to analyze, I'll go into something like an object store where a storage format like LansDB, where the vectorization happens, Iceberg, where the tabular format is stored, and for graph, poppy graph kind of is becoming very popular, right? So all these kind of primitive, engines and primitive storage primitives will be needed to do some historical analysis on the offline layer.
And I think that becomes also an important part of the whole knowledge engineering piece that we discussed earlier, right? Um,
Exactly.
yeah. So let's talk a little bit about, we touched a little bit on policy and governance, right? You know, um, Tell me about like in practice as people are building stuff, what does realistic governance look like right now?
There are two models in governance here. Um, One is agent become a service primitive and
Hmm.
do the work on behalf of a user, right? Or agent becomes a separate user who is just like another person in your workforce and does the work. So the identity piece is super important here. So if you want to treat agent as a workforce, one more engineer in your team or one more employee in your organization, you need to be able to define these system users as human users in your identity providers and use them across. And those agents will assume those roles and execute the work, or
Hmm.
they will assume that identity and do the work on behalf of that identity only. Then the second is, you as a agent creator, you created an agent, you published it for the organization to use, but as the invoker of that agent, my policy has to prevail. That's more complicated problem, where agent does the work but it impersonate you. So that's where some of these OBO on behalf of certain user kind of primitives that are becoming very popular, but there is not a very hardened system that has been built so far. I haven't seen that. Maybe I haven't seen everything, but based on my research, I haven't seen that a lot. I think that's an area that is super critical, because in going forward, you don't want to give super privileges to a agent, and because everybody in your organization wants to access that agent, and it should have a superset of all the access everybody has, right? You need to be able to allow an agent to work within a guardrail area or a guardrail sandbox with a dynamic policy enforced on top of it. And that dynamic policy should be built on who the user who invoked that agent. We need Nemo Claw is one of that, where similar kind of primitives are being built, but not like those are for personal agents. We need to think about how enterprise agents will have that OBO kind of flow with external injection of policies that agents can understand, and controls and gateways defined to control and enforce those policies when agents perform action. I think those are the areas that needs to happen. Investment needs to happen there.
Agents can be designed, by a few people, for a particular function, and then everybody who is in that function could take advantage of that with their credentials, and it's kind of acting on behalf of that user. And sort of keeping with policies versus service keys, which are very easy to then lose track of, like how access is being managed, right? um Actually, that is certainly an area of active work. Um, when talking about this governance and some of these capabilities at NemoClaw, and where how do you see the balance between speed of innovation and then keeping all this compliance together? Like how do you encourage teams to experiment fast, but still keep compliant?
I see compliance and security as accelerators.
Uh-huh.
They are not going to come in the way of innovation if you are doing them right. The way to think about them, as you need to think upfront about what are those primitive needed, and define the guardrails around it, and then set your users and agents free to operate within that guardrail. Think about a football game or a soccer game happening. You have rules in soccer, but you don't control every move of your players, right? The way to think about security governance is, enterprises who are serious about agentic workload, they need to go back, think through what are those broader security control and compliance control that are needed, and build integrations for that. And then not control every single move that the agent is going to do. It is, let the agents be set free, users be set free to build whatever agents. As long as you have these high level guardrails and gateways defined, you should be able to control any bad action done by a user or agent. We from today onwards, if we are serious about AI in next 5 years, we want to be a differentiated organization in AI. Then we have to treat AI just like any other human, a team member of our organization. And the way we define rules, compliance policies for the team members, we need to define those things for agents as well. It is easier said than done, but as companies, there are we need to think through how we want to do it. We have to think about, okay, NemoClaw has these primitives, OpenCell has some of them. How do we bring them together and build a very hardened guardrail layer or a control layer for our agents? And then after that, don't worry about um, reviewing every single agent flow. Does that kind of make sense?
Yeah, yeah, I think that totally makes sense. In fact, I would love to ask you, like, what questions do you think data leaders should be asking you? You've done a lot of research in the space. You've presented at many places. You're a thought leader. What one question do you think data leaders should be asking you, but they don't?
I think there are three, four questions that data leaders should ask. One is there is this madness that, hey, enterprise is going towards lakehouse architecture. Spark should be our preferred engine. I'm not saying Spark is the only one. Distributed engines are our preferred engine. We should go with distributed processing of data. That creates complexity. I have a patent in distributed data processing world, and the way I look at this world, if you do not need distributed processing, don't do it, right? Because you are signing up for complexity tax. Um, so first thing that the data leaders should ask themselves is my data really big data? If you actually ask this question seriously to our enterprises today, 70% of their data, which on top of which most of their critical decisions are being made, are actually not big data, right? Customer, it's a limited. I mean, if you are a B2B company, you do not have like 5 trillion customers. You will have a handful of them. If your orders, if you are again a B2B and most of our B2C company, you won't have like trillions and trillions of orders every day. You'll have max to max few million orders each day. So your most critical data sets are not big data. Then why are you signing up for that complexity tax? You need to ask yourself. You need to go back, look at your data platform, and say, okay, where is my 90% of my business decisions are being made? Is it on big data or small data? DuckDB is doing a really good job. They sense that okay, my most of the companies have tabular data, structured data, and most of these data sets are either monthly summaries, weekly summaries, small data sets around few hundred gigabytes, and single node processing is just like a library installed in a computer should just work. I think that shift has to come in the market where we should not just run after, hey, did this, so we should do that. We should think about whether our use case makes sense or not. And the second thing is, how big is my lake house? Most of the data leaders, when I talk and reinvent and ask these questions, they they say, okay, um my lake house is like 10 petabytes of data that I store in my lake house. It's not a feather in the cap. Don't think of it as a badge of honor, right? Because you haven't asked the hard question that what is all my 10 petabytes of data relevant? Why am I spending so much money if we are not making decision on the 10 petabyte of data? That's no one is asking today, right? Every data leader is taking this as a badge of honor that I have a 5 petabyte or 10 petabyte of data sitting in my lakehouse. We need to actually look at that number, go back, ask our engineering teams. And by the way, when I was with AWS, if you ask that question, you will see magic happening. Okay, so people will go back, look at their lake house, the portion of the lake house that they own. Probably 30 to 40% of your data will be deleted in next day. So you are saving 30% of your storage costs immediately. So I think those are some of the hard questions that needs to be asked. And the third thing is, is my data platform ready for these AI workloads? Because think about it. Why I'm saying this distributed tax is going to be a problem is because when things become expensive, people think the technology is bad. They don't see the other side of the problem, right? What is wrong in their platform? They don't want to see that. Think about the situation where today we have humans interacting with the data platform. Maybe they are creating 10,000, 100,000 queries in a day. You make it incredibly simple for the users to ask a natural language question, and agents are going to fire those queries. There'll be a stick growth in terms of number of queries that are being fired into your lakehouse. So this decouple of storage and compute is going to help you, but you are still using a distributed compute layer where you are going to be where you are going to bleed out money day in day out because you are generating a lot of more workloads that you are previously not generating. So now you need to think about that layer. How can we do single node processing for most of the high um, most of the important decisions that we are doing on your data platform. That shift needs to happen. Then last one, we talked about knowledge engineering quite a bit. I don't want to harp on that again, right? We need a knowledge layer on top of the data platform to be able to inform the agent which data set to use, when to use, why certain thing needs to be used, when it was last used, and whether the customer liked the outcome of that data set or not. So all this information needs to be curated, stored at a single place, so that agents can interact with your platform really well.
I think this is very well put, Mahesh, because I do agree that companies often get oversold into technologies that they don't necessarily need. But then that very complexity that you're talking about, the tax that you have to pay, is what is preventing people from taking advantage of AI, because now you have to get all your data is not ready because you have just owned a much more complex system than you needed to, right? It's a very, very valid piece of advice, I think, that every data leader needs to take note of and really say what part of my data is really impactful, has high ROI, and if I can keep that in a clean, organized way, I have a lot of value to generate, right? And you're right. There'll be more. I mean, because of the simplicity of asking questions, more people will ask questions, more SQL queries will get generated under the hood, and yeah, costs are gonna go up. So yeah, it's a much more it's a very wise piece of advice over there. Um,
Thank
yeah. Um, so I think this is a great note. And then I'm just thinking, from all the shift that you're seeing, especially on AI side, and given your thought leadership, where do you see like things maybe 3 to 5 years out from this sort of data platforming AI perspective? Um, you mentioned early on about all the automation that is coming in, how we manage data, right? What's your vision 5 years out?
I think um, I'll break it down into two parts. One is what will happen probably, in my opinion, in next 5 years, and then the second part of the question that I'm going to, which you didn't ask, but I'll still answer, is who are those companies and what do they need to do to win, right? In next 5 years, first few years, there'll be a lot of automations happening. Automations around data engineering, automations around text to SQL, automation around visualization, automations around troubleshooting, fixing, optimization, all these things. First 1 or 2 years, that's what is going to happen. There's a ton of knowledge engineering work, semantic views, semantic materialized views, semantic layers, knowledge engineering. All these platforms will come, but take that very consciously, what you really need. It is a lot of noise to um, kind of distract you quickly, because everybody is talking about a semantic view nowadays. Metric view is one of those concepts. Then semantic layer is another thing. Then someone is saying knowledge layer, right? I'm talking about knowledge engineering. So think about what you really what you really need. Um, if you are okay that you have good engineers who can write metric views in a way that your AI agents can make sense out of it, go for it. Don't if you are if you are thinking that okay, you need a better robust mechanism to manage your knowledge context through knowledge engineering, go for it. But you don't try to invest everywhere, because if you run in all directions, you will not get anywhere. So I think that's what you need to think through. Then the third set of things that are going to happen is data driven workflow. High stake decision making and actions are going to happen 3 to 5 years, at least 2 to 5 years from now. There'll be a lot of companies that will be built, a lot of enterprises will build those agents where they will take a bunch of high stake actions, not just decisions, the actions. I go to a doctor, I say, hey, here is my past history, medical history. I'm having this symptom. What do you think? That decision eventually, I think in next 3 to 4 years, that decision will be offloaded to an agent. It can go to your history, look at the data. What is your health history? Then what is the current medication that you are taking? What is the symptom? What what that agent thinks that is the um, right prescription to give you, and most of the things will be done. Doctor will just be a face of it. Just because there is human life involved, there'll be probably a doctor who will be like writing 5,000 prescriptions a day looking at these AI outputs. Um, so that is going to happen. The actual actions will be taken. High stake decision making, for example, vendor selection in supply chain, those things will be automated. Nobody today, there is a person who stands the decision that, hey, I'm the person, my neck is on the line, I selected this vendor for this part to be supplied. Those high stake decisions will be offloaded to agents. So all the actions that enterprises take, most of the actions will be offloaded. Where humans will come is high value decision making. What will be the strategy for the product? How do we go to market? Even though many of the suggestions will come from the AI agents and AI layer, human will still take those high stake decisions because not everything will be known to the agent. So I think that is what is going to happen in the next 5 years. Um, Engineering development cost is going to go significantly lower because AI agents will be more efficient in writing code. More, they'll be writing much better software. So the engineering cost will be there'll be AI cost, but actual engineering human cost will be low. LLMs will be commoditized; their cost will probably go down. That is my forecast at this point, prediction at this point. And then last but not the least, you will see a ton of creative infrastructure companies who will place the data center in fancy places, top of Himalayas or deep in the ocean or in the Mars, because we'll need so much of energy and so much of water and cooling requirement for these data centers that we would need to find all these places and to host the data centers. This is what is going to happen in next 5 years. On the other side, who are those companies who can build differentiated experiences? These are the companies who think now and build a right operating model for AI adoption. Not just operating model, they need to organize their teams in a way that they treat AI as a team member, not as something as a machine which is sitting outside. Um, then the companies which are going to be successful are going to build those harnesses to control the security and compliance for the agents. They'll build those primitives, they'll define those primitives, and control the high level outcome or the actions that the agent is going to perform, but they are not going to poke into each single move that the agent is going to make. The knowledge engineering platform will be super popular. People will build integrations into Wiki, Jira, Slack, GitHub, all these places where some knowledge is documented, stored, and bring this bridge between the structured and unstructured data through this knowledge layer. Last but not the least, those companies who will be successful, they will try today, move fast, fail fast, and course correct when they fail fast. If they don't do that, they won't be building a differentiation in next 5 years.
Fascinating, fascinating. Very well said. And I really like the point you were saying early on is that everybody's building a semantic layer and all that. And I feel like as data leaders, one of the important things is that don't get sucked into the FOMO when you are reading the LinkedIn news feeds and Twitter posts, because it looks like everybody's doing this. They're all buying this technology, or they're all getting the solution. So let me just go after that. I think your advice is very practical. Like, stay grounded in what you are doing and what creates ROI for you. And I think that's a great way to wrap the conversation. Yeah. Um, so Mahesh, very, very, on point piece of advice from you throughout the conversation. How can people stay in touch with you? Where can they follow your insights?
Yeah. I'm present in LinkedIn. My LinkedIn handle is Mahesh Mishra. People can reach out to me there. I write a lot of blog. You can stay connected with me through my blogs. Very recently, I started writing on Medium, so you can stay connected there. My handle is Mr. Mahesh Mishra there, so you can connect me over there. I'm not a social media guy, so not a lot of presence in Facebook um, or Instagram or anything like that. I think LinkedIn and blog post. That's how you reach out to me.
Yeah, thank you for joining us today. Fascinating conversation. Appreciate you taking the time.
Absolutely, it's a pleasure. Um, thank you for having me. We really had a great conversation. Looking forward to more.